Rigel, the blue warrior of the night sky. When you gaze at the constellation Orion, the legendary hunter, you'll spot a dazzling star at the bottom right, glowing with a cold, bluish brilliance. That's Rigel, the seventh brightest star in the night sky, and one of the most powerful and massive stars we can observe. Located 860 light-years from Earth, Rigel is a blue supergiant, belonging to spectral type Beta. That means it's burning fast and bright, like a fire unwilling to fade. Size and destructive power. Rigel's radius is 79 times greater than the Sun. If placed where the Sun is now, it would engulf Mercury, Venus, Earth, and even Mars. Its estimated diameter is around 110 million kilometers, nearly 3/4 of the distance between Earth and the Sun. It is 21 times more massive than the Sun, about 4.1 times 10 kilograms. But what's most striking isn't its size or mass, it's the luminosity. Rigel shines 120,000 times brighter than the Sun. That's enough energy to vaporize a planet if it comes too close. Extreme temperature. With a surface temperature of 11,800 C, Rigel is hot enough to strip any nearby matter into plasma. No planet could survive such proximity. It's a cosmic furnace, burning hydrogen into helium at terrifying speed. Since its birth, Rigel has shed mass equivalent to 3 suns through intense stellar winds. A brief life. Rigel is radiant but short-lived. The larger and brighter a star, the shorter its life. Rigel is just 8 million years old, the blink of an eye compared to the Sun's 4.6 billion years. When Rigel exhausts its fuel, it will explode as a supernova, leaving behind a neutron star. If the explosion happened today, it would take 860 years for its light to reach us. Altair and Vega, the love story of the Milky Way. Let's leave mighty Rigel for a gentler tale, the legendary love between Altair and Vega, better known as the cowherd and the weaver girl in East Asian folklore. They are not only myth but real stars, some of the most iconic in the summer sky. Altair, the fastest spinner in the sky. Altair is the brightest star in the constellation Aquila, just 16.7 light-years from Earth. It's a white star spinning at incredible speed, only 8.9 hours to complete a full rotation, compared to the Sun's 25 days. This speed distorts Altair's shape. It bulges at the equator, with a diameter 14% greater than from pole to pole. It has about 1.8 times the Sun's mass and shines 11 times brighter. Roar-like glow surrounding Alpha Centauri's system as seen from space. Though not a supergiant, Altair is graceful and swift, like a dancer among the stars. Vega, the pure radiance of heaven. Vega, the Weaver Girl, is part of the Lyra constellation, 25 light-years from Earth. It's a white-blue star of spectral type A0 volts with a surface temperature of 9,300 C, shining 50 times brighter than the Sun. With an apparent magnitude of 0.03, Vega is the fifth brightest star in the night sky. It spins rapidly, taking only 12.5 hours to rotate and may one day end its life in a smaller supernova. In astronomy, Vega is used as a baseline. Its brightness is defined as magnitude 0. Deneb, the lonely giant of Cygnus. Remember the summer triangle? It's formed by Altair, Vega, and Deneb, the brightest star in the constellation Cygnus. But Deneb isn't like its companions. It is a true beast of light. Located 2,600 light-years away, Deneb is one of the most luminous stars visible to the naked eye. Despite its distance, it still shines clearly, proof of its extraordinary power. Deneb is a white supergiant A2A with a radius 200 times that of the Sun. If placed at the center of our solar system, it would swallow Earth, Mars, and the asteroid belt. Though its surface temperature is only 8,500 C lower than Rigel, its colossal size gives it a luminosity 250,000 times greater than the Sun. Pistol Star, the energy cannon of the galaxy. Pistol Star may be the most energetic star ever observed, hidden in the Pistol Nebula near the galactic center. Located 25,000 light-years from Earth, Pistol Star was once thought to have 250 times the mass of the Sun, now estimated at 100 to 150 solar masses. This monster star emits more energy in 20 seconds than the Sun does in an entire year. However, it is shrouded in thick clouds of dust from a past explosion, making it invisible to the naked eye. Astronomers must use infrared telescopes to observe it, proof that the brightest lights often hide in the deepest shadows. Conclusion: the universe still burns. We've just explored some of the most astonishing and powerful stars: Rigel, Altair, Vega, Deneb, and Pistol Star. Each tells its own story, some ancient, some young, some lonely, some lost in mystery. And this is just the beginning. The Most Mysterious Stars in the Universe, Part 2. After exploring stars like Rigel, Altair, Vega, Deneb, and Pistol Star, you might think that the universe has no more surprises to offer. Part 2 of our journey takes us into the realm of the truly unimaginable stars so massive they can vaporize entire solar systems, and remnants of dead stars so dense they warp spacetime itself. Welcome to the domain of neutron stars, magnetars, and black holes. Ediacarinae, the unstable monster. In the universe, some stars don't live quietly. They erupt, rage, and threaten to explode at any moment. One such star is Ediacarinae, known as the ticking time bomb of the galaxy. Located about 7,500 light-years from Earth, Ediacarinae is a binary system of massive stars weighing 90 and 30 times the Sun, respectively. Together, they emit more energy than nearly any other stars in the Milky Way. In 1843, Ediacarinae experienced a mysterious explosion without dying. The event ejected massive amounts of material, forming the expanding homunculus nebula. Scientists believe that Ediacarinae could soon explode as a hypernova supernova, hundreds of times more powerful than normal ones. When it happens, its light might rival the Moon from Earth's view. By Canis Majoris, one of the largest known stars. Think Rigel or Deneb were enormous. Meet By Canis Majoris, a red hypergiant in the Canis Major constellation, 3,900 light-years away. This is one of the largest stars ever discovered. If placed at the center of our solar system, its surface would engulf Saturn's orbit. Its diameter is 1,400 times the Sun's, over 2 billion kilometers. By Canis Majoris has a chaotic atmosphere and is shedding mass at a terrifying rate. It is nearing the end of its life and is expected to go supernova soon, likely collapsing into a black hole, the eternal grave of matter. Scuti is second in size. Next, we meet Scuti, a red supergiant in the Scutum constellation, about 9,500 light-years from Earth. While not extremely bright, it is unimaginably huge. Scuti has a radius 1,700 times that of the Sun. Traveling across it at the speed of light would take over 8 hours. It's so vast that even light takes time to swim through it. Despite its size, its surface temperature is low, just 3,365, which makes it shine faintly and appear modest in brightness. But make no mistake, Scuti is nearing its final chapter and will soon explode in cosmic spectacle. Neutron stars are compact tombstones. When a massive star explodes but isn't large enough to become a black hole, it collapses into a neutron star, city-sized object with mass greater than the Sun. Imagine compressing all of Earth into a ping-pong ball. A teaspoon of neutron star matter would weigh about 6 billion tons. The gravity is so intense, you'd be crushed to atoms in a microsecond if you stood on its surface. Many neutron stars rotate rapidly, up to 700 times per second, emitting beams of energy like cosmic lighthouses. These are called pulsars, and we detect them by their rhythmic pulses. Magnetars, magnetic monsters. If a neutron star is the stoic elder, then a magnetar is its deranged sibling. Magnetars are neutron stars with magnetic fields 1,000 times stronger. Black holes, where time stops. When a supermassive star dies, it collapses into a point of infinite density, a black hole. Nothing escapes it, not even light. The core becomes a singularity, a place where physics breaks down. Brown it is the event horizon cross that, and you're lost forever. Time slows near a black hole. Light bends. You vanish from view. Some black holes are remnants of stars. Others lie at the centers of galaxies, devouring stars and planets like cosmic whirlpools. Conclusion: the universe devours itself. The universe isn't just about light. It's about darkness, absolute, consuming, and mysterious. From gigantic stars to dead remnants that warp light, Part 2 reminds us that the cosmos is wild, untamed, and far from fully understood. And this is only the beginning.